So let's look at our last segment as we look at the last question. That's question number 4. If you're in Form 1, Form 2, Grade 10, and if you are revising to write your Grade 12, this is good stuff, please. You can get to go through the question. It says a group of learners designs an inclined plane to help move a heavy box into a laboratory. The box has a weight of 800 newtons and is pushed along a ramp of length 5 meters. The learners apply a force of 200 newtons to move the box. So this is what the question is actually telling you. So what you can do, if you want, you can put up a simple illustration just to illustrate what is being done, what is being done. So if that is the box, the box has a weight. Remember, this is an inclined plane, a type of simple machine. The weight of the box is equal to 800 newtons. That's what they tell us, 800 newtons. So this is the box. Then we are told the length of this incline. So the length of that incline is simply 5 meters. Then the learners apply a force of 200 to move the box. So they are pushing it. That's the effort of 200 newtons, to push it in that direction. Then A says, calculate the useful work done in lifting the box vertically through a height of 1 meter. So remember, work done is equal to force times distance, but in this case the force is simply the weight of the box, where force is equal to simply the weight of the box. So it is going to be 800 multiplied by the distance through which it has actually been lifted. They tell us that it's 1 meter, so through 1 meter. So that will still give us 800 joules. So that is simply the useful work done in lifting the box vertically through a height of 1 meter. And that's what you needed to do there. All right, let's move on to another one there. It says calculate the work input by the learners. So remember, the work input by the learners in this case will be the force multiplied by the distance. So with what force were the learners actually pushing the box? If you still remember, they can just do it that way. If you still remember, the learners were pushing with a force of 200. And through what distance did they move? 5 meters. So meaning the work input by the learners will be equal to the 200, the force they were using to push it, times the distance which they covered, which is 5 meters. So the work input will be equal to, when we multiply that, that will give us 1000 joules. Then C says calculate the efficiency of the inclined plane. So if you look at the efficiency, in this case efficiency is equal to the work output over the work input. We can express it like this, then expressed as a percentage. So the work output is what we calculated there, which is simply 800. So you get your 800 joules divided by the work input, which is a 1000 joules, then multiply this by 100. So what will be our efficiency? Therefore, our efficiency, if we multiply it, to be 800 divided by 1000, whatever we get, times 100, and that is going to give us 80%. So you can try out this question if possible. If you can do it, it says explain why an inclined plane is useful even when the distance traveled is longer. Yeah. So why is it useful? Basically, it is because it actually reduces the effort that is applied. So even the distance, even when the distance is longer, you can simply say, you can simply say it reduces the effort applied. So it actually reduces the effort that is applied, and that is why we want to use an inclined plane even when the distance is longer, because it reduces the effort that you are going to apply. Thank you so much for watching. If you love what we do, please subscribe for more, so that then you'll be able to see more videos. If you're in Form 1, Form 2, you can also watch out other series that they can still help you.